So I'm here to talk about native mobile apps. So let's go back, way back in time when we talk about smartphones, and we'll talk about the beginning of smartphones when we talk about things like what. Yeah, no one cares, right? I mean, frankly, who cares about the BlackBerry and the old Microsoft phones? Honestly, but the mobile world, when you really get down to it, began with the release of this guy, the iPhone. Now, I'm pretty sure that most of the people in this room can remember the original iPhone launch event. One of the questions I want to ask you is, do you remember the initial talk that came out of Apple when they talked about developers developing applications for the iPhone? This is Steve Jobs' quote. If you notice, he's not talking about native applications, because when they first came out with the iPhone, they said, wait, native applications, just do it as web stuff. As we all know really well, that concept didn't go over really well, and now we have, well, this, right? So there's 1,500 applications for everything, including generating fart noises and whatever else you want, until they started cleaning stuff up. All these native applications, you write them in Java if you're on Android land, or Scala if you're adventurous. You can go and write Objective-C or Swift if you want to be on the cutting edge, and have some of the libraries in OS X land work for you. But I'm a web developer. So what options, is there things that I could do to just get going? And the concepts of what Brian talked about, of these hybrid mobile apps, started coming out. And people played with different ideas. So you had things that mostly boiled down to two groups. The web view apps. So these are the apps that you would launch a web view, point at a URL, and it would run. And it was normally embedded right in the application, so it wasn't going out to retrieve a web page necessarily. It was something hosted within the actual application, but it was still essentially just rendering HTML inside of a web view. And on the other extreme, you had compiled hybrid apps. And the two standard bearers for this are the Xamarin framework and the Titanium framework. These ones carry their own set of things, right? They compile down into real native pieces, but they had their own sets of problems. And at the end of the day, most of the people who looked at either of these as real solutions to their problems ended up feeling like this, right? They didn't quite work, and there was honestly a myriad of reasons why. The web view apps always felt sluggish. If you go and dig around, you can find all sorts of comments about people, and you find out that really what they were doing is running a web view app. The API support was always incomplete. So you wanted to do this one thing, and no one had written the plugin across to do it, and it was really the APIs for the web view applications themselves were very difficult to get into, and you had to get your stuff bundled in. They didn't look native, right? The web view application looked like a website hosted within an app. They didn't feel native. You pull things, and it would act like a website, not like an application. And that wasn't the experience that developers really wanted to give their users. It's not what they wanted to do. Compile apps had their own set of problems. They didn't really support everything. Xamarin, while really powerful and cross-platform, really wasn't geared at the actual UI portions of it so much as it was the application code. They could be difficult to debug. They could be buggy in unexpected ways. They can get pricey. The Titanium framework starts pricing up every month as you go. You have to pay to have access to it. And you have to learn entirely new languages. Okay, wait, again, I'm a web developer. I want to be able to work it. If there's ways I can take the work I'm already doing and apply it and get something that feels right to the user that they're actually using, then I want to be able to do that rather than learning an entire new language. If I'm going to do that, I might as well learn the native language in the first place, or writing something that doesn't feel right to the user. Neither one of these was really an acceptable solution. So we're going to rewind a little bit and talk about React. Now, I'm guessing there's a few people in this room who use React already. We've done a couple talks about it as a group. I'm sure that there's a few of us who are using it professionally already. React claims to be the V in MVC. Really, they're not trying to solve all the problems in the world. They're trying to be a view layer and something that can deliver your performant view experience to everybody and give you a way to compose your apps and build something that's understandable and easy to follow. So it functions around a few basic tenets. It's a component UI. So you're building components that you compose together. The components, when composed, form your application. Unidirectional data flow. React went against the grain when it was released. If you go back to Angular at the time, or even Ember at that specific moment in time, they were very focused on bidirectional data binding. Bidirectional data binding, as most of the people have found out, is not necessarily the best idea. It results in all sorts of performance issues as you start getting further down the road, and presents an entirely new set of problems that make your application really difficult to understand. React went the idea of saying our data flows one direction. It's a big circle. You make a change, it updates the application causes the view to update. It was consistent in how it operated, which made it easier to think about. And that gets to the last one. Because of these basic tenets, React claimed it was easier to reason about. Or for those of you who have not been in the developer community, you can understand it better, because we like inventing new words to say the same thing that everybody else has said for centuries. So when the Facebook folks started looking at what they were building for their mobile applications, they liked what the web folks had developed with React for developing their web applications. And they had a couple options when it came to employing the same techniques. They could just do what we did before, right? We could take React, hoist everything together and shove it in a web view and serve it that way. Well, that carries all the same baggage that normal hybrid applications contained, and you had this up and down experience. It didn't really feel right. Then they said, well, we could make native React. And they built, for example, Component Kit, which is a React implementation that's built within Objective-C. And you can write React-style applications within Objective-C. But there was a couple problems they ran into with this. Most of Facebook is web developers, the vast majority of their company. So they wanted to be able to leverage as much of their in-house knowledge as they could without having to have them go back and forth in different places. So they started working on React Native. React Native was first introduced to the community in January at F8, which is Facebook's big conference. They started talking about it and showing out some of the details of it, and they finally released the first version in March. Key information about this first version of React Native: it only supported iOS. There was no Android support, which we come into in just a second when we talk about the advantages of React Native. It takes that same component-based architecture that you got used to building user interfaces for the web and applies that same basic structure to user interfaces for native applications. It leverages the existing JavaScript ecosystem. You're writing your code in JavaScript just like you would if you were writing a web app. The difference is it directly relates, and I'm going to show this later, to actual UI components that are within the native operating system. So you're building real native applications. You're just doing it with JavaScript. It provides off-the-main thread execution, which they talk about, which is a performance benefit. So now you can have your application running on the JavaScript thread, which, if you don't make fundamental mistakes, can leave your main UI thread available to respond to user input very quickly. This can stop you from running into weird things where, oh, look, the application's doing something and now my app doesn't respond when the user touches the screen, which is never a good thing. It provides a direct bridge to native functionality. So if there is not support for some piece of the native API that you need, there's a direct way for you to go out and build that. It uses Flexbox for layout and CSS styling support. So if you're used to laying out stuff with Flexbox, if you're used to using CSS to style your fonts, to set boldness, all those basic functionalities, it's going to feel at home. They have to do this through a slightly different mechanism than a CSS style sheet, which we'll cover, but the basics of it are all going to be familiar to you. It's multi-platform, works for iOS, works for Android. Yes, I know that Windows Phone is out there, but no one uses it, so it's not really that big of a concern. More to the point, it is worth noting that people are actually out there working on React Native bridges to other things, including, oddly enough, React Native bridges to desktop environments, so that you could actually build a React Native application that would serve a Windows application on your Windows desktop. Same thing, people are fooling around with these different ideas, and that's probably where things are going to go in the React community long term, but that's down the road yet. It can work in existing applications. You've already built a big iOS application, right? And you want to start dabbling with React, you can actually add React Native into your existing web application without throwing everything away, and it will work. One last big advantage, which isn't something directly provided by React Native, but it's absolutely worth mentioning, is these technologies of code push and app hub IO. Is anyone in the room, besides Andrew, overly familiar with how long it takes to get an iOS application through approval from Apple? Week, 10 days. App hub IO and code push allow you to update the React Native bundle, push it to your clients, and Apple doesn't have a problem with this. There's a couple caveats to that. You're not allowed to massively change the purpose of your application, and you can't change any of the compiled code. So you can only change the JS portions of your code. So there's some borders around this, but if you find a big bug in your code, you can deploy an update without having to go through the approval process, without having to ask for an emergency update or any of those things. That's a major game changer in terms of supporting the mobile experience. Okay, so let's look at some examples. And this is where this presentation is a little bit different for me because I've been doing a lot of slide presentations lately and not so many that actually have a lot of code in them. Okay, so this is a React Native app. A good chunk of the code I will admit to liberally stealing from Facebook. But I'm more interested in showing you the ideas behind it than getting caught up in some of the details. Has anybody seen the game 2048? It's been floating around for a while, but basically you move around some numbers and your idea is to build up the highest number that you can possibly get. This app runs in both iOS and Android, and I'll demonstrate both shortly, and is an implementation of that game. So it's a reasonably complex game, but you get some of the basics. This is the tie-in for iOS. This is the tie-in for Android. We'll talk in a second because there is a mechanism for you to bail out and say, if I want my iOS experience to be fundamentally different than my Android experience in a certain place, I can do that by just adding an additional extension on a file. So let's walk through a little bit of the code just to cover a couple basic things. So I'm going to start with a real simple guy. So there's a couple interesting things here that we're going to take note of. So the first one is this styles. So if you remember how I mentioned a few minutes ago that you can use CSS and Flexbox to do your styling and your layout arrangement. What's going on here is now you can define cell size, width. Most of these things, while they might look a slight bit different than the exact CSS property, are going to be very familiar to you. So instead of background dash color, it's background camel case color. Not a big change. Most people are going to be able to pick that up and fundamentally understand what's going on. It's quick to pick up, easy to understand. Once you do that, all you have to do to make use of it is point at your style sheet. You can actually point at a whole array of style sheets if you want, which we'll show an example of in a minute. And by pointing at that style sheet, now that element picks up those styles. We're going to look at tile. So tile's purpose is to actually show the numbers on the screen, which we'll show in a moment when I start it up. And that's going to be my next thing. But tile involves animations. You see this animated call. It involves more complicated styles where you can see our text styles are set by all these pieces. So I can say, these are my base styles for each value. If the value is greater than 4, then I want you to include this one. If it's greater than 100, I want you to include 3 digits. If it's greater than 1,000, I want you to include this one. So each step along the way, it can modify the styles as it goes and override them. So let's actually open up one of these apps and take a look at it. Make sure we're exactly where I'm at. Open. So starting this app is pretty much as easy as clicking the play button. You're going to see it spin up the React Native server. So when you're in development for React Native, it runs a local web server that it can go and grab the JS bundle that it creates off of. That JS bundle is served locally. When you actually go to create a production deployment, you actually include that JS bundle directly, and there's no server running. It loads it in directly into the JS core within iOS. You see it start up, and then way back here, if I can get the right one. You get our iPhone, which doesn't fit at all in this one. But you can see, here's our app running. This is the result of much smaller screen than I use normally. Where's what I'm looking for? No. There we are. So this is 2048, right? I can take and slide stuff across. You notice the animations, just like you can get in a real native app. I can take, grab these. You can see the color change that just happened as the numbers gathered together. All this basic code runs just the way you'd expect and feels like a native application. And to reiterate that, what I want to show, is this the right guy? I always forget. Yep. This is the view hierarchy. So this doesn't look like much from this, but what you can start to see is the actual native views that are being rendered on the screen. So each one of those lines, as I go across, represents a native view that's being rendered. This is all compiled from Java, is all being generated by JavaScript in real time as the application's running. So every one of those JavaScript classes, if I come back to my tile and look at the render method, where you see it generating a view, that is a native view. That is not anything that's generating HTML. It's an actual native iOS view. Same thing, where it uses board. Now it's actually going off and grabbing another whole component that I've written. This guy. So you can go through, same thing, define styles, and set up another component. You can compose the components together just like you can in React. You get all the power and understandability of React and being able to gather these components together to make a larger application that you can follow, but now you can actually get native feel and performance out of it. And that's the big key there. So the other nice thing about this is the same application, once I get my Android simulator up, React native run, can compile an Android application and run in that environment. While this is going on, so this is actually compiling Java code, building the whole thing together, getting it ready to bundle. It will actually point and run against the same web server that can serve off the bundles as the iOS one. And now you can have both applications pointing at the same code base and running off the same code base. Now, people have looked at both iOS, even if you are the biggest Apple fanboy in the world or biggest Google user in the world, you've seen both iOS and Android, right? Do things look exactly the same on iOS or Android? No, right? They just don't. And there's good reasons for that. One of the nice things that you can do is, actually, let's pull up the Android app now that should be open. So here's that same application. Behaves the same way and gives you the same feel. If you come back to our application, you can see that right here, I'm importing game end overlay. People are familiar with ES6 imports. So ES6 imports, if you point it at / some file, it will normally go and look for a file that ends in .js, or if you, depending upon you set up your transpiler at .jsx or whatever other extension you want. The bundler for React Native is actually got a couple conventions set up in it. If you end your file in .ios.js or .android.js, it will use that file when it'll use that extension when it builds for that particular platform. So if I'm building an iOS application and I end my file in .ios.js, it will prefer that file over anything else. So if I want to differentiate between my two different platforms, I can simply make a version of the file for Android and a version of the file for iOS, and it will use the correct one at the correct time. So if you look, I've got my game end overlays for when my game actually ends and I can no longer make moves. I have both an iOS and Android version that include different text to the user. So now if I want to actually make I want to have the same basic application with a lot of the same idioms across it and set up some of the same basic pieces, I can do that, but I can also still separate them out enough that I can now build an application that feels like an Android application for my Android users and an application that feels like an iOS application for my iOS users. And when I talk about your native apps feeling like native apps, that's a really important detail and one that gets frequently overlooked. So that ability to target for my specific environment gives me the final bit of flexibility that I need to build real native stuff one time that can run in both environments and feel correct to that environment. So it allows you to do the pieces that you need for each place. Additionally, if there's some piece of functionality that you are leveraging on one environment that isn't available on the other, you now have a way to gate off to make sure that, hey, I want this piece of functionality, for example, near-field communication, right, was built into Android long before it was available on iOS. If you wanted to make that available within your app, you could do so without having to have figuring out some weird thing to block it off from iOS, just by handling different imports. So it gives you a lot of flexibility and a lot of power to separate off things and build real native feeling applications. Okay, a couple other nice things about this world. Come back over here. One of the things that is a problem in native land is when you make a change, normally you have to go through the steps of recompiling the app. It's a slow cycle time, right? I make a change, I recompile, 30 seconds later, now I can see my change. I can make a change directly within here. One, two, three. There it goes. I don't know if you actually loaded or not. You're going to be the funny one today, aren't you? Are you going to cooperate? Sorry, 1 second. That's not the button I wanted to hit. One of the advantages you get when done properly, not rotating the screen, come on. That's why I prefer the iOS when I'm a little more versed with it, but it seems to have died on me. Okay. Paused, that's right, there we go. We'll just stop you and start you over. I will show this from the beginning. Okay, there we go. So put this back to where it was and come back here. So as I change these numbers and save the file, the advantage that I get is I can hit refresh. Why are you still? Okay. I can reload that JS directly within here. In fact, I can even go as far as hitting enable live reload, and as I save my JS, it can actually automatically update my view. This is a massive improvement in your cycle time and workflow when you're working with mobile devices. It allows you to very rapidly see the changes you're making and see how they affect your user. Because it's running that web server that we're talking about, can actually pick up the changes and notify the system that it's been updated. So it can actually directly tell it to do so. The other thing that you get, if you notice, is debugging in Chrome. And this gives you the Chrome debugger, and you can actually view your code. Right, here's my iOS stuff. It gives you source map support and everything, so you can actually go through and see each little bit, set breakpoints where you want, debug through your JS, just like you were running a website with React. That's another immensely powerful utility. It allows you to do a lot. So those couple features give you some bits and pieces that you don't necessarily have. They improve your state of being. Those you can debug in Android land, you can debug in iOS land. The idea is to make how rapidly you can develop faster, enabling you to get things out quicker, which is the story at the end of the day, right? You want to be able to deliver working code. Okay, let's hop back over here for a minute. So let's get real about what's going on here. Is this what we're dealing with here? Did Facebook give us this magical thing that can answer all of our problems? It probably looks a bit more like this. Not to be mean. There's a lot of nice stuff here. It's dressed up pretty well, but there's a lot of hidden things in there. So let's talk about it. React Native is still a young framework. As I said just a minute ago, the first public release of React Native was less than a year ago. It hasn't been out very long. If you look at the React Native thing and look at the open issues, and this was from earlier I want to say this was about 1 in the afternoon. I took the screenshot to update this slide. There are 940 open issues on Facebook for the React Native repository, which, that sounds like a lot, and then you realize that there's also 210 open pull requests. The fact of the matter is the React Native team is a bit swamped at the moment, so much so that Facebook is actually rapidly hiring people to work on the React Native team to help them try to catch up. The community has caught on big on React Native to the point where they're generating it. This is actually an improvement. At one point, I want to say the issues log got to more than 1,500 open issues on React Native, but they're rapidly trying to address the issues. It's just there's a lot of stuff to get through. They're trying to build. This is where the Dennis Nedry comparison comes in, right? They're trying to build a system that's working with 2 major platforms that are inherently different from one another across at least 3 different programming languages, if you don't count the other JVM languages as well, and trying to make all of this stuff work with one higher level abstraction that works for everybody. And as we all know, the law of abstractions is they leak and things get funny in weird places. So let's talk about some of the other stuff. There's CSS styling, kinda. So here's where it gets funny. It supports something that looks like CSS, but the first thing to realize is it's not CSS. There's no cascade. If I set styles on a view up here, they don't automatically make their way to a view down here. That's an important difference from what you're used to working on the web. That's not how things work here. You have to set your styles where you want to use them. That's just the reality of it. The support is still incomplete. There are places where you would expect certain styling attributes to be available where they just plain aren't. And then you get into other things where even if the support for a style is there, it doesn't work right. A recent one that I think is coming out in their next release is border radius didn't work right on Android. It just didn't. It just looked wrong. So they're trying to build the equivalent of your web browser in native applications in 2 different platforms and make everything work. So there's a lot of details for them to work through with that. It's multi-platform, kinda. Whoops, I did that again. Android support wasn't actually even added until September. So if you remember, I said a second ago, React Native was released in March. Your Android support didn't come till September. So all of that 1,500 problems I was describing, that's a good chunk of that was iOS because they're just digging into the Android stuff to figure out where all the Android stuff doesn't work. The ecosystem support is scattershot. So one of the other problems you get is, remember that saying you get the whole being able to leverage the JavaScript ecosystem? Well, people are building up more stuff specifically for React Native to tie back to the native pieces. And you'll get libraries that you pull off NPM that support iOS that don't support Android, or support Android and don't support iOS, depending upon which one they were working on at the time. And unfortunately, as everything else on NPM, people are really good at starting things and not completing them. So you pick up this thing thinking, oh, look, I've got this thing and it supports iOS now. They'll add Android in the next few weeks. Or never touch the library again. So that's another problem. Android debugging is, I got it to work once. I think my coworkers may have gotten it to work a couple more times, but I'm not even 100% sure that's right. It unfortunately devolves into a lot of console logging. Ian's back there shaking his head, going, no, please don't make me do that.
Everything on iOS.
Which is fun until you get an Android bug that you're trying to figure out and going, So while it's getting there and there's a lot of power in this system, it's still really immature. So coming to conclusions on some of the bigger picture of this stuff, and then I'm going to take questions because I'm thinking there's going to be a few. The idea is awesome, right? The React is a really powerful idea, and people have grabbed onto it because it's really easy to understand, and it's really powerful on its core. People are talking about it in all sorts of locations, and it's getting a lot of traction. Its ideas have been so powerful that even Angular and Ember have picked up a lot of ideas from React because of the power of the abstractions that they made. It's fun to work with. It's a lot of fun React Native is honestly a lot of fun to just pick up and go get to work with. It doesn't take a lot to get something on screen for somebody who's not overly familiar with native development. You can spin up, do the global install of React Native init a directory, and have a hello world up in about 10 seconds. And then you can start editing and changing that and getting actual things up on the screen very shortly thereafter. And all the concepts, especially if you've used React before, are going to be very easy to you. And the documentation on the site, while incomplete, gives you at least a very good quick start on the components that are available to you that they provide already. So it gives you a lot of place to start with. It still has a lot of growing to do. There's no way around that. They said they're building a system that's trying to tackle a really big goal of going across these two different platforms and being usable and workable for both of them. And there's a lot of work for them to do. React is about to go to an actual release and not be in pre-release version. My guess is React Native may be 6 months to a year away from being not officially pre-release. This is despite the fact that there are notable applications of React Native already in deployment, including ones from Facebook themselves. Expect to have some places where you get bugs that just don't make any sense to you and don't seem logical at all. React Native provides polyfills for some JavaScript APIs that you're used to. For example, the fetch API will make AJAX calls for you. We dealt with a bug in the fetch polyfill for no apparent reason, and it was only in one of the two operating systems. So you're going to get fun things like that you have to deal with. Is that they're still doing a lot of work. The last big note here, it doesn't alleviate the need for some platform-specific developers. They are not trying to write APIs for everything in native. So if you're not dealing with something that they have already written something for making AJAX calls or for dealing with the perspective changes, or I think they've got the geolocation stuff in there. There are holes in the API that don't go to native. If you need that bridge and it's not available out there, you need people who know how to write Objective-C or Java or Swift. You're going to still need those skills. That some of the more complicated things when you set up applications, especially if you're dealing with hybrid applications, like if you already have an existing application, you can't just go, well, we'll get rid of our iOS team and we'll just go and start picking off, because you're going to lack the requisite knowledge on how to integrate it properly into your application. You can't get rid of that skill set, but it allows you to maybe bring more people into the fold who can contribute to your project. I left specific time in this one for questions because I understand that the framework's big and there's probably going to be questions. And I'm willing to demonstrate some of the more details of the application that I just ran as well. But that's the focus of React Native. It's really trying to provide you the environment you're used to working with in JavaScript for React in a native application that feels right. And with that, any questions? Good. No, I was going to you. Sorry. There's no good way to say person I don't know.
What does interop with like the native platform look like when you're like writing the JavaScript code? If like you have some service or something. When you go and write the Java or there's a specific bridge that you talk to on the native side, and then it gets exposed as an object within it. It's a top-level object that you can essentially make what mounts to static calls. So be aware that they're not necessarily instance-based, but they're static calls that you're making back and forth. So you have to. There's some work to do there, but it's a pretty straightforward interface actually. Way and back. Mm-hmm. Nope. React Native is completely free and open source. The only trick to React and this is true for React Native, Flux, basically the entire. Goes across the board for the way Facebook handles their open source libraries. You have to sign an agreement if you contribute code to their repository. The agreement that you are signing basically gives the copyright for your code to Facebook, so that Facebook is the copyright holder on the code base. The license that they originally had, and this is true again for both React and React Native, had some clauses in it that people were not happy with in terms of the license grants, and there goes the screen. Those have been actually removed on the later licensing. So no, it's actually completely free and open source. It's free to use under the current license. Oh, that'll do it. Mm-hmm. That'll fix it.
You talked about Flux, right?
Yep.
Can you use Flux?
Yes, you can use Flux. You can use Redux. There were, up until about a month ago, there were some issues using some of the Flux frameworks. And that has to do with how React was included in React Native. It was included as a locally sourced vendor lib instead of being properly depended upon as a pure dependency. They fixed that in version 0.18, I believe, or 0.19. So now they're actually pure dependencies. You can actually use Redux, you can use Flux, you can use any of the Flux frameworks.
Okay.
Yep.
Is React Router working on?
There is a React Native router, but React Router by nature won't work because there's no URLs involved. There's an entire navigation system in React Native that works along the lines of the basic navigation system. There's a couple different ones that they've got out there. They have direct native wrappers around both iOS and Android, and then there's an experiment. There's another one that's like Facebook's wrapper around both things, which is their own implementation, which doesn't feel quite the same, but is pretty close. So there's a couple options that you're allowed to play with there.
More of a comment. There's actually a React developer group called React Flux. They just had a Q&A with one of the React Native developers. They're going to be posting a transcript of tomorrow. So if any of you guys are more interested, he touches on a lot of the stuff he talked about, some of the deficiencies and where they need community help. So if any of you guys want to play with React Native or contribute to it, that would probably be a good resource.
Carl or I can actually put a link for React to Flux if you up on the SEM.js board.
So here's the fun part with testing. The testing support is a little bit funny around the actual React Native components yet. We've had some luck with doing some weird shimming to get shim in React. I think Ian did most of that work. React in that place so that we could use shallow rendering to test it.
There's a library called React Native Mock that one of the main developers of React Native created, and it essentially swaps out React Native components for just empty React components so that you can run the testing there.
Yep. So there's some ways to do it, but it's not perfect yet by any stretch of the imagination.
In a similar vein for testing, so let's say you have the .android and the .iOS. Do you
Yep.
need to let it compile through like all of the React stuff in order to test that? Because I can't imagine like a typical testing library would know how to resolve it.
So what you're going to do in that particular case is you would actually have to, if you want to have both Android and iOS ones, you probably have to write specs for each one of them and include them directly. So remember how I said it's going to assume the .js portion on the end? When you run the test, it's not really running in the Android or the iOS environment. So what you'll do is you'll write a spec that specifically includes the variant that you want. But you're probably going to run into some weird issues if it has dependencies on further ones. So there's going to be some hoops to jump through there. Like I said, the testing stuff is the answer to testing is it's doable, but it's not perfect.
One more question about testing.
Yep.
I don't know if you have any experience with, you were talking about like the bridge for interacting with native code. Is that something that's like mockable or like testable within there?
Honestly, that one I can't answer. I'd have to imagine that with the so there's a short answer and a long. I would say there's a short answer and a long answer to that. I don't know that you want to test the bridge itself because that's pretty well tested. The way React handles taking the stuff that's properly set up across that, it'll map things correctly for you. There's no probably necessary need to test that. But once you're doing that, now you're just dealing with native iOS code or JS code, so you can mock in on the JS side or probably the same thing on the iOS side.
I was more wondering if you can like fake it somehow so that you can like, if you can like fake out like the calls that it makes or whatever, that's possible.
I said you're essentially, if you're calling over to the native side, you're essentially going to be sending what amounts to being you're going to be making a call against a bunch of arguments that are native things. So you're going to, from a testing perspective, it's no different than calling it in any other testing perspective. I'm going to pass in a string here, int here, and a dictionary here, right? At the end of the day, the things I'm passing in are fundamentally native objects, so testing it isn't any different than any other place.
So the first thing when I think about native and bridge is memory leak. Do you have these things?
So you need to be careful of it, but so the answer to your question is it's not really a big problem if you're dealing with an app that was written from scratch in React Native, because you're going to have one instance of the bridge. It doesn't keep rebuilding it, so that bridge lives for the lifespan of the application. If you build a hybrid app, that may not be true. So it's making sure that you properly don't hang on to things that you're not supposed to hang on to, just like any other development system, right? If you're not using something anymore, you make sure that you clean up after yourself.
How much support is there for existing native libraries?
So hang on, let me actually pull it up real quick. And there's me. So the APIs that they've already got set up, you can kind of get a feel for here. Alerts, the animated stuff, they have ways to talk to the camera roll, layout animation stuff which deals with state changing stuff. That's actually almost all internal. Net info, so they've got a lot of stuff there. And then you get some of the polyfills for things like geolocation, network stuff, timers. So there's a fairly broad support already.
So, like regarding things like CocoaPods, though, like anything like that.
So the answer to your question is they actually removed direct support for CocoaPods from React Native a little bit ago, but people have filled in the gaps. There's another package manager that's popped up called React Native Package Manager, RNPM. RNPM is actually, it's not as bad as it sounds. RNPM is a light, I know, as soon as you say there's another package manager? Really? RNPM is a really light wrapper around NPM, because most of the way the community is kind of settling is to deploy their packages within NPM, but then you need to take and link back the native stuff into your application. What RNPM does is solve that problem. So it does the install from NPM. It's just a call through to NPM to do the install of whatever library you do, and then it will actually go through your application and properly link in the pieces from the native pieces into your application. So that's the problem that RNPM is trying to solve. But if you start going through the different libraries, you'll see libraries that have RNPM that are set up for RNPM, and also set up for CocoaPods, and also give you manual install instructions. So the answer is the community is trying to be really overly broad about what way you want to include said library in your project, to not pigeonhole you and say, oh, this is the only way we're supporting. Most of them are being pretty broad about supporting multiple different ways. The bigger problem gets to the one that I touched on, which is this library only supports iOS and this library only supports Android, and I need that functionality in both places. So that's actually the bigger problem at the moment, is the varying support for the platforms rather than how difficult it is to integrate one of the libraries into your application.
Have you ran into any issues with with all that code sharing? And now this tool that you're using on your iOS app, you have to use the Android app, and you make a change for Android that breaks the iOS app or anything like that. Have you had to do anything to impose a way to keep those stable or let things?
I'm actually going to defer a little bit to the guys on my team who have worked a bit more. Ian and Chris have worked quite a bit more on the React Native stuff than I have up to this point. I don't think that's been a major issue, but there's been some, I think.
Yeah, what's nice about it is because of the library loading stuff and there's no compile time, like when I'm developing, I'll actually have the iOS simulator right next to the Android simulator, and it's all from the same React server. So if I make a change, I'll see it both update immediately on both. So that sort of takes away a lot of the pain points there, because you'll immediately see if something breaks. Obviously, you're not going to be perfect, and given, like Matt said, that some of the Android stuff hasn't quite caught up to the iOS stuff, there will be differences. But given the feedback loop of changing code and the fact that it updates immediately, and you can have them both running from the exact same code, so I don't have to, go change my Android code and then rerun the Android server because it's all from the same server. It's a pretty good system, yeah.
Yeah, and what Chris talked about, I didn't have it enabled when I was running these couple applications, but when I've done development in there too, I have live reload enabled as well, and it's a nice change even from our web project doesn't even actually have live reload set up yet, so it's really nice to be able to make a change, hit save, and like a moment later see it pop up on the screen. That's
I think they just
a nice advantage.
enabled hot reloading as well.
Yeah.
It goes a step further and keeps your state, swaps out the components.
Any more questions?
If you happen to bring a jQuery plugin in, does it work?
You can include jQuery. I don't know that would be a wise idea. So here's the catch. I wouldn't use any jQuery plugins that are designed to work with the DOM, because the DOM doesn't exist. More to the point, I don't know that I'd include jQuery, period. And this comes to a much more fundamental thing. Download size is still an issue. These are mobile devices you're sending this data to, and you still want to try to wedge down and keep the code that you're delivering to your client as small as possible. So be smart about what libraries you bring in, and bring in libraries with a purpose. Definitely favor small, very purpose-specific libraries over very large libraries in this environment.
Good.
Yep.
Two more follow-up questions. And when you said about data size, so when is the main application sent over? When you install the application first time, and then you have the incremental
Yep.
update?
The answer is, even if you're using CodePush or AppHub, when they download the application, that includes the JS bundle with it as part of the application. When you compile your application, into an actual runtime one, it includes the JS bundle as part of that.
And the update is based on the actual file.
Yes. If you're using,
The whole new file is sent over. It's
okay,
diff-
so if you're using CodePush or AppHub, what they do is they go back and look, you push a new JS bundle up to the central server. The application is designed to then go and query the server, find out if there's a new file, if there's a new version in place, then it will download that version and swap it in place. If you don't use something like AppHub or CodePush, the only way to deploy a new version of the JS is to deploy a new version of the application, just like any other iOS or Android application.
Thank you.
Yep.
What would you say is like the largest cost right now of going this route as opposed to just developing two different native applications? Like the most important question to ask yourself.
So let's answer that question from this perspective. iOS and Android developers in this area are not easy to find. The single biggest cost for any development project you're going to talk about is the developers for the project itself, not the software that they're using to build it. So when people start bringing up the cost of Visual Studio, and this is coming from a non-Visual Studio fan, I use Sublime Text, right? Or the cost of development tool X. The reality is, when you are developing software, your single most expensive and hard to find asset is the developer to develop that software. So while, yes, there are costs involved in this, the fact that you open up your development pool, I think, starts to outweigh a lot of those costs. The biggest cost is probably gets into some of the things I mentioned about it being a relatively immature framework and dealing with some of the hoops that you need to jump through in places that you didn't necessarily expect them, if that makes sense. So it's the weird debugging things that end up costing you time, or just get the learning curve of how to build animations properly and get them to feel right and all those different pieces. There's learning involved in that, but you're going to get learning involved in that if you're dealing with people new to the iOS or Android development environments in the first place. So your single biggest thing to me is that it opens up the pool of the number of people you can bring into your project and how quickly you can work on it.
Are things like analytics and crash reporting like supported well, or?
So that's actually still on our plate to look at. You can get analytics. So like I said, there are APIs there in place to make calls back for things. I haven't tried to integrate New Relic or Track.js or any of those systems directly into it to know if they run into any problems. I'd imagine that there's likely some hiccups there. But you can build, that stuff is eminently doable. You can also take the approach of using things that are already written for the native side for crash reporting and use the bridge to talk back and send those pieces of data back. Any other questions?
Is there any proposed stack for this? Like mean?
I'm sorry?
Proposed stack layer, mean stack kind of thing?
So you've hit upon my single biggest complaint about the React community at the moment, and that's that there are about 1,500 ways to do just about anything. The community hasn't yet coalesced around an absolute winner in a lot of terms. There's a couple places where you're starting to see certain winners seem to develop. In terms of the Flux or Flux-like frameworks, Redux seems to be heading towards getting the lion's share of the mind share in the community. That said, it's by saying it seems to be, it still has probably less than 50% of the overall Flux usage out there is Redux. So there's still a lot of stuff to go there. But this is the biggest difference between using React or using Angular or Ember. You have to make decisions about the libraries that you're going to include. There isn't a lot of consensus, and what consensus there seems to be will probably be different in a week. At some point, the hope is some of that will start to slow down and become more tenable for all of us to manage. React, the ideas in React are really powerful, but that's one place where the community as a whole needs to make the decision that we're going to start to coalesce around certain ideas, because if we don't start to coalesce around certain ideas, as I mentioned, Angular and Ember have started picking up ideas from React, and if people don't coalesce around certain ideas, the basic user friendliness of those other ones, the ease to pick up, will start winning out over the basic power that React tends to provide.
Are you guys using this to build production level stuff right now?
We've got one piece in production already, and we're working on 2 or 3 major pieces right at the moment that hopefully in the next month or so will be also out there. So yes, the answer is ours is very much a hybrid app that we're using right now. Any other questions?
How much native app development experience did you have before you started?
I changed a bunch of strings once.
So you're an expert.
Yes.
10 years plus.
No, literally that's what I did. I updated some strings in the application.
Perfect, because that's exactly where I am.
Yep. And to answer the question, if you're building a completely from scratch application, you are probably, in not dealing with the hybrid issue pieces of it, you're probably going to be working almost entirely in JS land anyways, and so you're probably not going to even notice it.
My follow-up question is, when you're learning React Native, how long did it take before you had to like raise your hand and talk to a native app developer for like, why is this happening?
The answer is, I think I've run into that one major time, but that was not on, that had more to do with integrating code push into our application, actually. And that's really on the far extreme edge of the React Native ecosystem, right? It's dealing with this weird piece that was going on there. The only other place that I've run into, and I still don't have great answers for, is actually around the Android debugging piece. That's still been funny. Any other questions? Cool. Thanks, guys.